My name is Gary Shields. I'm the director of the Disruptive Technology Laboratory of the Naval Surface Warfare Center, Carderock. And what you're seeing is our production of our first Vanka style boat, which is a composite structure from bamboo and foam. How we got here was the Disruptive Technology Laboratory is an innovation engine. And about 5 years ago, we started with the idea that we could 3D print a submersible, a swimmer delivery vehicle. And we demonstrated that with Oak Ridge National Labs down in Tennessee. We printed a 30-foot hull of a submersible. That has started an industry. That has started industry to actually start 3D printing hulls for submersible systems. After that, we kept being challenged by others to produce things really rapidly. Where I'm talking about 6 to 8 week spans of time of rapid insertion of innovation and ideas. And one of the last groups to do that was the Joint Staff Innovation Working Group at the Pentagon. They called us in and said they wanted us to demonstrate the ability to 3D print solutions for damage aboard a craft in real time. And they gave us 6 weeks to have prototypes on the desk of the Joint Staff Working Group to show how we would be able to do this versus industry. So we took on the challenge, and what we found was the constraints were too hard because we thought we would additively manufacture our way out of this problem. And what we discovered is that constraint space forces us into an innovation mode. It addressed our creativity. By operating on constraints, that's how you get to minimum viable systems fast. So we thought we were going to additively manufacture our solution set. But what we ended up doing was, because we had no time, no money, no top cover, no tools, we started to forge for things that we could produce under our own power. And we came across this foam material. And the first iterations of this is we demonstrated with the foam that we could use a soft structure as a mold, and we could rebuild a lift gate for utility craft. We could plug a hole in the side of the ship. We could put a skeg in the water, and we could do a couple other things. And you could do that really, really fast on board ship where additive manufacturing would not function. And if your additive systems were hit aboard ship, you didn't have capability anyway. So we started really thinking about what does a damage control locker of the future look like. But at the end of this event, we played a game with ourselves with the foam and said, could we build an unmanned vehicle? And we had this device called a HoloLens, which was a legacy from our 3D printing of the submarine days. And we grabbed it and we put a hologram CAD file of a PT boat in. And we also put CAD drawings in and a material supply. And we went down to our old forging lab, and there was a pit of sand that looked about that size of this JMIC container. And we filled it with sand, and we used the HoloLens to cast a image into the sand of a PT boat. We carved out that hull form. We put in a motor, put in a radio, and poured in foam. And in thought instantiation, we had a unmanned vehicle in the water in less than an hour and a half. And when you start doing things like this, we started imagining containers filled with foam and subsystems, and demonstrating the ability to produce 2,100 small little boats in 70 hours with a 3-man team, with no tools and no machinery. That kind of changed the way we looked at it. So the Marine Corps called us and said, well, we were actually at the Office of Naval Research with one of our little foam boats, and the Marine Corps was going to have us 3D print on a beach a submersible. And they saw the little foam boat and said, oh no, we want you to do that, but we want you to scale that up to demonstrate the ability to move 10 tons of material across a wet gap. So we and demonstrated at what's called an advanced naval technology exercise, an ANTEX, and they gave us about 8 weeks to do it. So we came up with this idea eventually of what we call sushi rolls, which are these round rolls that are built by staking out with found sticks and a tarp around one of these JAMIC containers, a round cylinder that you would fill with foam, and that would allow you to tow 3,000 pounds of stuff between island chains. String them together, that gives you the ability to tow 10,000 pounds. That led us, those exercises led us to where we are today, where we finally played this war game with Leslie Wilhelm and her team at Indian Head called Wi-Fi. And the result of the game led us to have the need and the requirement to produce this Bonka type craft. This is a demonstration of a craft that can survive sea state 2 or 3 plus, carry about 4,000 pounds of material, travel about 40 miles an hour right now because of the engine size that we have in it, and travel about 56 miles one way. It takes about 15 hours to produce. It weighs about 4,000 pounds. It can carry 3,000 pounds of material. And once you're done, the beach where you built it looks like before you built it. There's no signature remaining. So this is how we think about what we call asymmetric industrial contingent warfare. Building at the speed of tactical need under the arc of fire.